In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a product. It says evaluate the following limit using L'Hopital's rule. Limit as x approaches 0 from the right of 9x tangent negative 2x plus pi over 2. So if we plug in 0 for x, we get 0 here. If we plug in 0 coming from the right on this side here, we're going to end up with tangent of pi over 2, which tangent of pi over 2 when you're coming from the right, that's going to be, that's going to approach, it should approach, let's see, should approach infinity, I believe. And it does, yes, it approaches infinity because actually at tangent at pi over 2 is undefined. But if you're coming from the right, you're going to be approaching infinity there. So you got to think about how the graph of tangent looks, and the graph of tangent will be going off to infinity until you hit that undefined point. So we end up with 0 times infinity here, which is indeterminate. Now we need to create a fraction out of this limit, and to do that we're going to separate tangent into sine over cosine. So we're actually going to write this as 9x sine of negative 2x plus pi over 2 over cosine of negative 2x plus pi over 2. And the reason we want to do that is so we can apply L'Hopital's rule, because L'Hopital's rule says we can take the derivative of the numerator and the derivative of the denominator over and over and over again until we find the limit. So we're going to do that here. Limit as x approaches 0 from the right. We're going to do the derivative of the numerator. And you can see that this is going to be a product rule. Over derivative of the denominator, which is going to be a chain rule. So let's start with this product rule. We would say that, I'm going to write it down here, u is equal to 9x, u prime is 9, v would be sine negative 2x plus pi over 2. And then v prime, I'm going to kind of leave some room here, v prime is equal to, derivative of sine would be cosine negative 2x plus pi over 2 times the derivative of the inside, which is negative 2x plus pi over 2. So v prime is going to equal, if I take the derivative of the inside, that's negative 2. This would be 0. So I end up with negative 2 cosine negative 2x plus pi over 2. So we're going to write that up here. We're going to have the limit as x approaches 0 from the right. We're going to plug in our product rule here. So we got u prime times v. So we're going to have 9 sine of negative 2x plus pi over 2 plus, well, actually minus, because of that negative, we're going to take v prime times u, so that's negative 18 x cosine of negative 2x plus pi over 2. And that's all going to be over derivative of cosine negative 2x plus pi over 2. Well, we just did that. Actually, we did not. We did the derivative of sine. So we need to do the derivative of cosine. Derivative of cosine would be negative sine negative 2x plus pi over 2 times the derivative of the inside, which is negative 2x plus pi over 2. So chain rule on this one. We end up with the limit as x approaches 0 from the right. And we're going to leave, let's see, we could factor a 9 out. I think we'll just leave it. So we're going to say 9 sine of negative 2x plus pi over 2 minus 18x cosine negative 2x plus pi over 2 all over derivative of negative 2x would be negative 2. So I multiply that times the negative there, and I get 2 sine negative 2x plus pi over 2. Now I'm going to evaluate this, and when I plug in 0 into the function, first of all, I get cosine of pi over 2. 0 would cancel out this 2x piece, and I'd get cosine of pi over 2. Cosine of pi over 2 is 0, so I get 0 times this x value, which is 0, so this whole piece cancels out. I'm going to have minus 0 on the right. If I plug 0 into sine, this would be sine of, this is 0, so I get sine of pi over 2. Sine of pi over 2 is 1, so I end up with 1 times 9, which is 9, over, on the bottom I end up with, again, sine of pi over 2, because this will cancel when I plug 0 in. So sine of pi over 2 is 1, times 2 is 2. So I end up with 9 halves. So I'm going to say this is my original function, f of x, right here. So I'm going to say that limit as x approaches 0 from the right of f of x is equal to 9 over 2. And that's an application of L'Hopital's rule.